In this video, we'll solve a second-order non-homogeneous differential equation, and the differential equation is y double prime of t plus 6y prime of t plus 9y of t equals t times e to negative 3t. So the solution of the differential equation is formed by the general solution plus the particular solution. So let's calculate each of them individually. So the general solution, yg, we want to start with that. That solution is found by setting the differential equation from the left side equal to 0. As you notice, I dropped the t. I still consider the y as a function of t, but it just simplifies my computations. I don't carry all that with me. Now, in order to solve this differential equation, we find the characteristic equation by replacing a y of t with e to rt, and when we do the differentials and everything, we end up with this equation, the derivatives. We end up with this equation, which can be factored in r plus 3 squared equals 0, which means r equals negative 3. It's a double solution. Right, so r1 equals r2 equals negative 3. So the general solution that we wanted to find is going to be c1 e to negative 3t plus c2 t e to negative 3t. So we'll get back to this information later. Now, the particular solution, so we start with the general solution just because in this case, we notice that the double solution that we got, r equals negative 3, it's the same with this exponent here. So the right side, the term in the right side contains the same number that we obtained here. What does that mean? Well, that's going to help us figure out the shape of the particular solution. So in this method with undetermined coefficient, it's more like a judicial guessing. We are trying to figure out the type of the solution we have. So now, because we have the term t, which is linear, we expect to get a term of the form at plus b. The exponential one is e to negative 3t, so we copy that. But also, because this r was a double solution, we are going to add a term of t to the second in our problem, in our particular solution, in the shape of the particular solution. If r equals negative 3 was a simple solution, so the other solution was 5 or 9 or 3, then instead of t squared, we would add a term of, or a factor of t, just t to the first. Double solution means we add a t to the second. So now the next step that we have to do is we have to find the derivative of y, then we have to find the second derivative of yp and replace them into the equation to figure out what a and b are. So let's begin. So the particular solution prime is using the product rule here. So I'm going to do at to the third plus bt squared, just that's going to simplify my computation. And then I have to differentiate that. So using product rule, I get 3at to the second plus 2bt e to negative 3t plus at to the third plus bt squared times e to negative 3t times negative 3. So we can do a little bit of algebra here and end up with this. Now let's do the second derivative. So we get 6at plus 2b minus 9at squared minus 6bt times e to negative 3t plus we copy the parentheses 2bt minus 3at cubed minus 3bt squared, and then we differentiate the exponential, which is e to negative 3t times negative 3. We do a little bit of algebra and we end up with this. So I did all the computation, I factor out e to negative 3t, and then I added like terms. So now having the y particular and its derivatives, what I'm going to do is replace them into the initial equation. So is going to be like this. Y double prime of t, so I'm going to copy what I just got here. So it's going to be 9at cubed minus 18at squared plus 9bt squared plus 6at minus 12bt plus 2b. And I also have the term e to negative 3t, but I also notice that yp prime has e to negative 3t, yp has e to negative 3t, so I can put e to negative 3t at the very beginning and put everything else in factor out in the parentheses. Now, the next term is plus 6y prime, so y prime is this one, and then I have to multiply by 6, so I get plus 18at squared plus 12bt minus 18at cubed minus 18bt squared, and then I have to add 9y, so 9y, which means plus 9at cubed plus 9bt squared, and everything equals t e to negative 3t. So e to negative 3t times, and now let's see if we have any like terms. So I have 9at cubed and this one, and then I have another 9at cubed and negative 18at cubed, so this cancels. Negative 18at squared plus 18at squared cancels. 9bt squared with 9bt squared minus 18bt squared, it's 0. Negative 12bt plus 12bt, 0, and we end up with 6at plus 2b equals t e to negative 3t, or in other words, 6at plus 2b equals t. So, a linear equation from one side equals the linear equation from the other if the coefficients are equal. So, 6a is the coefficient of t on the left side equals 1, which is the coefficient of t on the other side. 2b is the constant on the left side equals 0 because that's the constant on the right side. So, we end up with a equals 1/6 and b equals 0. So, the particular solution, it's t squared times 1/6t e to negative 3t, or is 1/6t cubed e to negative 3t. So in other words, the solution of this equation, it's y of t equals c1 e to negative 3t plus c2t e to negative 3t, which is the general solution, plus 1/6t cubed e to negative 3t, which is the particular solution.